Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on correlation part 1. Today we are going to discuss on the introduction to correlation, the definition, different types of correlations, coefficient of correlation and properties of coefficient of correlation, and also methods of finding coefficient of correlation. In that, I would like to solve one problem on Karl Pearson's coefficient of correlation. Now, coming to the introduction part, the study of characteristics of only one variable such as marks, weights, heights, ages, sales, etc. is called univariate analysis. So, the study of characteristics of only one variable. In that case, we consider we deal with marks of students or weights of some persons or else heights of some persons. We deal with only one variable, that is called univariate analysis. If there is some relationship between two variables and we are dealing with two or more variables, for example, let us consider two variables, then the study of characteristics of two variables such as price and sale, price and production, demand and supply, height and weight, similarly weight and age, or wages and cost of living, fertilizer used and productivity, etc. This is called bivariate analysis. Here we deal with two things. So, that is why bivariate analysis. If there are more than two, then that comes under multi. So, univariate means we deal with only one variable. Bivariate, two variables. And the correlation refers to the relationship between two or more variables. The correlation refers to the relationship of two or more variables. Correlation measures the closeness of the relationship. So, using the correlation, we can measure how the two variables are close to each other. And coming to the actual definition of correlation, simply it is a statistical analysis which measures and analyzes the degree or extent to which the two variables fluctuate with reference to each other. That means the correlation measures the magnitude of the relation. For example, there are two variables x and y. We know that both x and y are related. X is related to y. In correlation, we don't find what is that exact relation between the two variables. Here we measure how the two variables are close to each other. That means how much they are close. So, we calculate the magnitude of the relation between two variables. So, correlation expresses the relationship or interdependence of two sets of variables upon each other. For example, I have the variable x and y. So, let us consider some set of values. For example, 5 values for x. Similarly, 5 values for y. Now, correlation measures is there any relation between x and y, and if there is any relation, how strong it is. So, we calculate the magnitude of the relation between two variables using correlation. So, one variable may be called the subject. So, in that independent variable is called subject, whereas dependent variable is called relative. So, correlation expresses the relation or interdependence of two sets of variables upon each other. For example, if there is some relation, for example, in general in mathematics we consider y equal to f of x. Let us consider the function f of x in which y is f of x. Let us draw the curve of this y equal to f of x. So, here this indicates the relation between x and y. It represents the relation between x and y. Here x is the independent variable and y is the dependent variable. So, here the independent variable is called subject and dependent variable is called relative. Now, types of correlation. The correlation is classified into many types such as positive and negative correlation. So, this positive correlation is also known as direct correlation and negative correlation is inverse correlation. And how can we define these two, or on which basis we can decide whether the correlation is positive or negative? That is direction of change of variables. For example, as x increases, y also increases, then the correlation is positive because here the direction is the same. Similarly, as x decreases, y also decreases. In this case also, since the direction is same, it is positive. For example, if x is increasing, y is decreasing, so reverse direction. In that case, the correlation is said to be negative. Similarly, vice versa. So, the correlation is positive and negative depending on the direction of change of variables. Similarly, simple and multiple correlation. It depends on the number of variables. For example, if we are finding the correlation between two variables, that is called simple correlation. If you consider more than two variables, then that comes under multiple correlation. The third one, partial or total correlation, and this depends on the variables. For example, we are considering some variables by excluding some other variables. That is called partial correlation. If we consider all the variables without excluding any single variable, that comes under total correlation. And the last, linear and non-linear correlation. This non-linear correlation is also known as curvilinear correlation. This depends on ratio of change in variables. That means, if the ratio of variables is uniform, then the correlation is said to be linear. And if it is not uniform, it is varying differently, then that comes under non-linear or curvilinear correlation. So, these are different types of correlations. Coefficient of correlation. The coefficient of correlation is denoted by R, which gives the magnitude of the relation between two or more variables. Here, we deal with simple correlation. That means we consider two variables x and y. So, the magnitude of the relation, that means how strongly these two variables are connected, or if there is any weak relation between these two, that can be obtained by finding the correlation coefficient R value. So, therefore, the correlation coefficient is denoted by R, and that R lies between -1 and 1. So, -1 less than or equal to R less than or equal to 1. This is an important property. The correlation coefficient lies between -1 and +1. So, here including -1. So, R can be 1 including 1, R can be -1, and in between negative and positive we may have 0, or R can be any other value that lies in the interval -1, 1. And if R equal to 1, the correlation is said to be perfect and positive. If the correlation coefficient value R is 1, then the correlation is said to be perfect and positive. That means strong relation. The two variables are strongly related. Similarly, if R equal to -1, the correlation is said to be R equal to -1. Again perfect but negative, since the value is -1, negative value. So, if R equal to either 1 or -1, the correlation is perfect, but the direction differs. So, in the first case R equal to 1, positive correlation, R equal to -1, negative correlation. And if R equal to 0, after calculating the value of R, if we obtain 0, then that means there is no relation between x and y, since the coefficient of correlation R is 0. So, the value of R is independent of change of origin and scale of measurements. So the value of R doesn't depend on changing the scale of measurements. And two independent variables are uncorrelated. So here the point is very simple. Two independent variables. If I say that X and Y are independent, what does it mean? They doesn't depend on each other. If they doesn't depend on each other, there will not be any relation between X and Y. So two independent variables are uncorrelated. That means obviously you will get R equal to 0. There will not be any relation between X and Y. Now, methods of finding coefficient of correlation. So there are many methods to find the coefficient of correlation, different methods like graphical methods, mathematical methods and so on. In graphical methods, scatter diagram and simple graph. Just by drawing the simple graph, you can obtain, you can identify or you can study the characteristics of the two data points, and then you can identify whether there is any relation between those two variables or not, just by studying these graphs. And mathematical methods, Karl Pearson's coefficient of correlation, this is the main important one, and Spearman's rank correlation coefficient. There are two different types to find the correlation coefficient R mathematically, and method of least squares. So here we are going to deal with mathematical methods only, not the graphical methods. So mainly the Karl Pearson's coefficient of correlation and Spearman's rank correlation coefficient. Karl Pearson's coefficient of correlation. A British mathematician, Karl Pearson, suggested a mathematical method for measuring the magnitude of linear relationship between two variables, which is known as Karl Pearson's coefficient of correlation, denoted by small r, is given by R equal to, you see this is the formula, sigma capital X into capital Y by under root sigma x square into sigma y square. So simply R is sigma capital X into capital Y. What is capital X? Here it is clearly mentioned. Capital X is x minus x bar, where x bar is the mean of x values. And then capital Y is y minus y bar, where y bar is the mean of y values. So R is given by sigma capital X into capital Y, where that capital X is small x minus x bar, capital Y is small y minus y bar. Simply the deviation of elements from the mean. So x minus x bar denotes the deviation of the elements from the mean. Similarly y minus y bar. Similarly y minus y bar. Now R equal to sigma capital X into capital Y by under root sigma capital X square, square the values of x, multiplied by sigma y square. So to find R, first we need to calculate what is capital X, what is capital Y, the values of capital X and capital Y, then sigma x square, sigma y square, sigma xy. So whatever the values are required, simply calculate those values and substitute in this formula. That gives the coefficient of correlation. And there are many other formulae also to find the coefficient of correlation. One of those, few of those formulae are the covariance of xy by sigma x into sigma y, where sigma x and sigma y are standard deviation of x values. This sigma x is standard deviation of values of x, and sigma y is standard deviation of values of y. And there is another formula, R equal to sigma xy by n into sigma x into sigma y. So you can use any formula, but this is the simple and standard one, because in the given problem, the values of x and y will be given. X values, the table will be given with these two set of points. X values, y values will be given. It is easy to calculate x bar, then y bar. How to find x bar? Sum of all values of x by total number of values of x, sigma x by n. Sigma y bar, sigma y by n. After calculating x bar and y bar, let us find capital X, x minus x bar, capital Y, y minus y bar, and then what are the required ones? Those values will be calculated. So construct a table which gives the required values and substitute those sums in this formula. So Karl Pearson's coefficient of correlation measures the magnitude of the relationship between two variables given by R equal to sigma capital XY by under square root of sigma x square into sigma y square. Let us solve a problem on Karl Pearson's coefficient of correlation. Calculate the correlation coefficient between the heights and weights given below. So in the given data, heights in inches given 57. Calculate the correlation coefficient between the heights and weights given below. Height in inches 57, 59, 62 and so on. Weight in lbs 113, 117, 126 and so on. Now we need to calculate R. What is the formula to find R? Sigma capital X into capital Y by square root of sigma x square into sigma y square, where capital X is x minus x bar, capital Y is y minus y bar. So to find capital X and capital Y, first we need to calculate x bar and y bar. So how to find x bar? Sum of all values of x by n. Total how many values are given? 1, 2, 3, 4, 5, 6, 7, 8, 9 values are given. So sum of all values of x 57 plus 59 plus so on plus last value 57 divided by 9, which results as 60. The average of x values is 60. Similarly, y bar is sigma y by n. So 113 plus 117 plus so on, the last value is 112 by 9, and which results as 120. Hence, x bar is 60, y bar is 120. Now we can construct a table using which we can find sigma capital X square, sigma y square, sigma xy and so on. Let us construct the table first. So these are the values of x, height x, 57, 59 and so on. And these are the values of weight, y values. Actually what we require in the formula, we need sigma x square, sigma y square, sigma xy. So we don't need this sigma. Height small x is given here, weight small y is given here. Now to find capital X is small x minus x bar is 60 and capital Y is y minus y bar 120. Let us calculate capital X values. 57 minus 60 minus 3, 59 minus 60 minus 1, 2, 3, 4, 5 minus 5 and minus 2 minus 3. In the formula we need, what is the formula? R equal to sigma capital X into capital Y by under root sigma capital X square into sigma capital Y square. We don't need sigma capital X, so don't calculate this total. Even if you calculate, what you will get? Minus 3, minus 1, minus 4, then minus 9, minus 11, minus 14 and this is 5 plus 5 plus 4 plus 14. You will get 0 because the sum of the mean deviations from the actual mean, the sum of the deviations of the values from the actual mean gives 0. So we don't need this capital X now. We need sigma capital X square. So square the values of x. Minus 3 whole square, 9, 1, 4, 9, 16, then 25, 25, 4, 9, and this total is sigma x square is 102. Similarly, let us calculate capital Y values. 113 minus 120 minus 7 minus 3 6 6 10 9 minus 9 minus 4 minus 8, and we don't need sigma capital Y, we want sigma capital Y square. So square the values of Y: 49, 9, 36, 36, 100, 81, 81, 16 and 64. Now let us add all these values. So sigma Y square is 472, and the last one, the last column, we need to calculate sigma capital XY, which is in the numerator in the formula. So sigma capital X into capital Y. Now minus 3 multiplied by minus 7, 21, minus 1 into minus 3 plus 3, 2 into 6, 12, 3 into 6, 18, 4 times of 10, 40, 5 nines are 45, minus 5 multiplied by minus 9 plus 45, minus 2 into minus 4 plus 8, minus 3 into minus 8, 24. So by adding all these values, sigma capital XY equal to, so we have all the required values. So R equal to sigma capital X into capital Y by under root sigma x square into sigma y square. So R is given by 216 divided by under root 102 into 472, and here the answer is 0.98. So almost equivalent to, nearby 1. That means the two variables are strongly related, almost equal to 1. So this is the magnitude of the relationship between these two variables x and y. So correlation measures the magnitude of the relation. Using correlation, we don't find what is the exact relation. We don't need that. We calculate the magnitude of the relation. Coming to the summary of today's session. In today's session, introduction to correlation, the quotient of correlation and methods to find quotient of correlations. In that, Carl Pearson's quotient of correlation, these topics are discussed, and also we have solved one problem. That means we calculated the quotient of correlation for the given data also. In the next session, again we solve some more problems on quotient of correlation. This is for today's session, and we will meet in the next session. Thank you.